2024 A-Level Combined Mathematics Paper 1, Part B, question number 11, Part B. This question has to do with factors of polynomials, the factor theorem, and the remainder theorem. The question says, let fx be equal to x cubed plus px squared plus qx plus p, where p and q are the real numbers. It then says the remainder when fx is divided by x minus 2 is 36 more than the remainder when fx is divided by x minus 1. Given this information, we are asked to show that 3p plus q is equal to 29. It then says it is also given that x plus 1 is a factor of f of x. Using this information, we are then asked to show that p is equal to 6, q is equal to 11, and we are then asked to factorize fx completely. Finally, we are asked to hence solve fx equal to 3 times x plus 2. Now to start off with this question, the first thing we need to do is use this fact right here, where if you have fx in this form, then the remainder when you divide fx by x minus 2 is 36 more than the remainder when you divide fx by x minus 1. We need to use that and the remainder theorem in order to find an equation that we can then use in order to show that 3p plus q is equal to 29. So to start off, what we're going to do is use our knowledge on the remainder theorem and say, if fx is divided by x minus 2 and we get a remainder, the remainder is going to be f of 2. We can prove this by the fact that if you have a remainder, what that means is, let's say we have f of x equals p of x times q of x plus r of x, where q of x is our quotient and p of x is our divisor. Now in this case, if we have a 0 for p of x, let's say x0, where if you substitute x0 into p of x, you get p of x0 being equal to 0, then in that case, if we substitute everything in the equation, we can see we get f of x0 on the left hand side. On the right hand side, we get 0 here, since when you substitute x0 into p of x, you get 0, so we get 0 plus r of x. And therefore, f of x0 is going to be equal to r of x0 when we have an x0 which makes the divisor equal to 0. Now here importantly, we have a order 1 polynomial that we're dividing by, and therefore our remainder is going to be order 0. So that means that x0 doesn't actually matter here, since our remainder is just a constant. Due to that, we can say directly that f of x0 is just equal to the remainder. Now using this information, what we're going to do is use this fact for both the very first one and the second one, where we say fx divided by x minus 2 and fx divided by x minus 1. So we can say for the remainder when we divide fx by x minus 2, we can say since x minus 2 is order 1, remainder is order 0, which is a constant. And therefore we can say constant. Therefore, the remainder when fx is divided by x minus 2 is going to be equal to the value that we get when x minus 2 is equal to 0 for x, which is going to be f of, and here we can see, to get x minus 2 equal to 0, x must be equal to 2, and therefore we get f of 2. So from this we can see the remainder when fx is divided by x minus 2 is directly f of 2, and we can say it's directly f of 2 since we know that the remainder is a constant. Now we can say, by a similar argument using the remainder theorem, when we divide fx by x minus 1, we are going to get f of 1 as a remainder. So we can say, by a similar argument, because I don't want to write the exact same argument again, we can say, therefore, the remainder when fx is divided by x minus 1 is equal to f of 1. Now, what we know is that this remainder is 36 more than this remainder. And therefore we can say, therefore, from information given we can say the remainder when we divide by x minus 2, which is this thing, which is f of 2, is equal to f of 2 is equal to the other remainder, which is f of 1 plus 36. Since f of 2, or the remainder when we divide by x minus 2, must be 36 more than the remainder when we divide by x minus 1. Now what we can do is to substitute in f of 2 and f of 1 in order to finally get the equation that we're looking for. So if we do that, we can see, since f of x is equal to x cubed plus px squared plus qx plus p, when we substitute, we're going to get x cubed, which is 2 cubed, plus 2 squared times p, plus 2q plus p being equal to 1 cubed plus 1 squared p plus 1q plus p plus 36. Now simplifying, we can see we have a p here and a p here, which we can cancel out. We have 1q here and 2q here, and we have 1p here and 4p here. 2p is 2 squared p here, which is 4p. And therefore, if we take this to this side, we can see we get the 4p minus 2p, 1p, which is 3p, which is what we wanted, plus q. Therefore, we can see we get 3p plus q equal to, and if we ignore all of those terms, we can see we have an 8 here, we have a 1 here, and we have a 36 here. So we have 36 plus 1 minus 8, since the 8 is on this side. Now taking that 8 to the other side, we can see we get 36 plus 1 minus 8, which is going to be 3p plus q equals, and here we get 37 minus 8, which is 29. And therefore we get our equation 3p plus q equal to 29. And with that, we've solved the first part of the question. Now for the second part, it says it is also given that x plus 1 is a factor of f of x. Now from factor theorem, we know if you have certain value that is a factor of another function, then when this thing becomes 0, the corresponding x value substituted into this thing is also going to give us 0. Therefore we can say if x plus 1 is a factor of f of x, then by the factor theorem, if we substitute in the corresponding value of x, that makes x plus 1 equal to 0, which is in this case x equals minus 1, into here, f of minus 1 is going to be equal to 0. Therefore, we can see f of minus 1 equals 0. Now substituting in minus 1, we can see minus 1 cubed plus minus 1 squared p plus minus 1q plus p is equal to 0. And we can see if we substitute, we get minus 1 plus p minus q plus p equal to 0, which translates to 2p minus q equal to 1. This is going to be called equation number 2, and we're going to go up and call this equation here equation number 1. Now what we can do with these two equations is to use them in order to find the values of p and q. Now we can see if we just add them together, the minus q here and plus q cancel, leaving us with only p. So if we do that, we can do 1 plus 2, and we can see we're going to get 3p on this side, 2p on this side, which is going to add up to 5p, and on the other side we have 29 and a 1, leaving us with 3p plus 2p equal to 29 plus 1. So we get 3p plus 2p equal to 29 plus 1, and we can see we get 5p equal to 30, and therefore if we do that 5p equals 30, we get that p is equal to 6. Now we've solved p. Now what we can do is to substitute p into either of these equations in order to find q. If we do that, we can see, let's say we take equation number 1. From equation number 1, we can get 3p, which is 3 times 6, plus q equals 29, which means that we have 18 plus q equals 29. Taking q to the other side, we can see we get q equals 29 minus 18, and therefore q is equal to 11. And with that, we have also solved p and q. So now we know the values of p and q, and therefore we can rewrite the function in terms of p and q. So if we do that, we can see, therefore fx is equal to x cubed plus 6x squared plus 11x plus 6. There we go. We have now found f of x. Now what we're finally asked to do is to factorize completely f of x. So what we can do with, we can start with is the fact that fx has a factor of x plus 1. Since we know that we can take advantage of that and directly try to factor out x plus 1 and see what we get left over. And here we can see, since f of x is degree 3, when we factor that out, we're going to get a degree 2 polynomial. And we all know how to factorize easily a degree 2 polynomial. So if we do that, we can see we're going to get fx equal to, and if we start factorizing on the left hand side, we can see if we take out an x plus 1, since we have an x cubed here, and the only way to get x cubed is to multiply x squared by the x that we have here, we're going to get x squared in the other polynomial that we have, and similarly, we have a term in the middle that's the x term, and at the end we have a constant term in this polynomial, and we can see, since the constant term can only come by multiplying 6 by this one right here, we can see that this constant term must be equal to 6. So therefore, we have x squared plus something plus 6, where this something is an x term. So we can see we have an x here, and all we need to do now is to simplify the constant term here. Now considering the in-between bits, we can see we have 11x here. Now this 11x can only come from this 6 being multiplied by this x, and this 1 being multiplied by the coefficient here, and this x. Now we can see, since this 6 and this x give us 6x, but we have a total of 11x here, we need 5 more x to come from multiplying this 1 here by the term in the middle. Therefore, this term must be 5x. And therefore, our equation for f of x is x plus 1 times x squared plus 5x plus 6. Now famously, this thing right here is simply x plus 2 times x plus 3. We know that since if you multiply two numbers together, you have to get 6, and when you add them, you get 5. By extortion, we can see the only two numbers that do that are 2 and 3. And therefore, our term is x plus 1 times x plus 2 times x plus 3. And therefore, f of x is equal to x plus 1 times x plus 2 times x plus 3. And we can underline that and call that our answer for the complete factorization of f of x. Now finally what we need to do is to hence solve f of x equal to 3 times x plus 2. So now if we go down and do that, we can see if we do f of x equal to 3 times x plus 2, we can see since we have this equation for f of x, we can therefore substitute and say, therefore we must have x plus 1 times x plus 2 times x plus 3 being equal to 3 times x plus 2. Now at this point you might be tempted to just divide both sides by x plus 2 and cancel it out, but we can't do that since x plus 2 being equal to 0 is also a solution for this equation. And due to that we can't divide it. So for now what we need to do is just factorize everything and then get our final answers being equal to 0, at which point we can then say either of the terms that we have could be equal to 0. So what we're going to do here is to go take this 3 here to the other side and take x plus 2 and this x plus 2 as a single factor. Now doing so, we can see we're going to get x plus 2 times a big factor, which is going to be everything else other than the x plus 2 that we're going to have. Now when we factor out the x plus 2, we can see we have an x plus 1 times an x plus 3, but then we also have a minus 3 here. So therefore we're going to have x plus 1 times x plus 3 and a minus 3. And that is all going to be equal to 0. Now considering this, we can see we can simplify this down, and this 1 times 3 and the minus 3 here would cancel out. So doing so, we're going to get x plus 2 times, and on the inside we can see x times x, x squared. And then we have x times 3, which is 3x, another 1 times x, which is x, added together is 4x, so therefore we have x squared plus 4x, and 1 times 3 is plus 3, and then we have a minus 3, so minus 3, and that is all equal to 0. Now here we can see, when we cancel this out and this out, we have x squared plus 4x in here. Now we can see the x squared plus 4x term here has a factor of x in it, which we could take out. Doing so, we can see we're going to get x times x plus 2, and then if we take that x out, we're going to be left with x plus 4. And therefore we have another factor of x plus 4. and that is all equal to 0. Now here we can see we have a product of three terms, x, x plus 2 and x plus 4, and their product is equal to 0. Therefore, either one of them could be equal to 0, and therefore we have three solutions here. The first is x equals 0. The second is x plus 2 equals 0, which means that x is equal to negative 2. And the third is x plus 4 equals 0, which means that x is equal to negative 4. So we can see the solutions here are x equals 0, or x equals minus 2, or x equals minus 4. And these are the three solutions to this question, and that is the very last part of this question. So now finally let's go up and discuss the marks awarded for this question. So at the start of the question, when you use the remainder theorem and say the remainder when fx is divided by x minus 2 is f of 2, and similarly the remainder when fx is divided by x minus 1 is f of 1, and then when you say from the information given, therefore f of 2 must be equal to f of 1 plus 36, writing down this line gets you 5 marks. Now after this, when you correctly substitute f of 2 by substituting x equals 2, and then you get this expression right here, you get 5 marks. And similarly, when you correctly substitute f of 1 and get this expression right here, you get 5 marks. Now after this, when you simplify down, in order to get 3p plus q equal to 29 as the final answer for that part of the question, you get another 5 marks. Now after this, when you use the second fact, where x plus 1 is a factor, and you use the factor theorem to say that therefore f of negative 1 must be equal to 0, you get 5 marks. After that, when you correctly substitute x equals negative 1 and get this expression right here, you get 5 marks. And finally, when you get that 2p minus q is equal to 1 and call that equation number 2, you get another 5 marks for that. Now after obtaining equation number 1 and equation number 2, when you then combine them and obtain p and q, for obtaining p like this, you get 5 marks correctly, and obtaining q, you get another 5 marks. Now after this, when you correctly substitute p and q into f of x, and then you immediately use the fact that we know that x plus 1 is a factor to factor out x plus 1, and then you write that fx is equal to x plus 1 times the other factor that you're going to get, which is x squared plus 5x plus 6, and you write that fx is equal to this. This step alone gets you 5 marks, and then the step after it, which is where you then factorize x squared plus 5x plus 6 as this and this, gets you another 5 marks. Now after this, when you then write down the solution for fx equal to 3 times x plus 2 by first factorizing, when you take the factorization like this and substitute, you get 5 marks for that. When you then take this part out, the x plus 2, and you have the remaining part inside, which you can then simplify, and you simplify it down to obtain x squared plus 4x, which you can then rearrange to x times x plus 2 times x plus 4, and you write that that is equal to 0, you get 5 marks for that. And finally, when you said that this product of terms being equal to 0 means that one of them is equal to 0, and therefore x could either be equal to 0, or x plus 2 could be equal to 0, therefore x could be equal to negative 2, or x plus 4 could be equal to 0, i.e. x is equal to negative 4, and you write down those as your 3 final answers. That gets you another 5 marks. So that's going to be all for this question. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.